what if you're given this scenario that there is a number p to the power n, okay, and then you have another number, it is q to the power n. The difference is now you have different base but the same powers, okay. So what happens when you have to multiply those two numbers? And that is where the fourth law of exponent comes in. It states that when you have two numbers that have different base but the same powers, the net result of this multiplication operation could be stated as p times q, and the power comes as n to this total, okay, meaning the same power comes to the product of these two bases, okay. All right, let us put some numbers to it to understand this concept, okay. So my first number is 6 to the power 4, all right, and I'm multiplying that with a number, and the second number is 3 to the power 4, all right. By this law, I'm stating that the net result should be 6 times 3 to the power 4, all right. But let's expand, all right, that is my net result. So let us see how the product really comes when we expand this multiplication. 6 to the power 4 is, it can be rewritten as 6 multiplied by 6 4 times, correct? And 3 to the power 4 is 3 multiplied by 3 itself 4 times. Simple enough, right? Okay, so the simple way to prove is, let's just solve them individually. So 6 multiplied 4 times by 6 is 1296. Simple enough, right? And 3 multiplied by 3 4 times is 81. So now all I'm supposed to do is find the product of these two numbers, okay? And that happens to be 104976. Okay, on the other hand, if I were to expand this number, the net result that I obtained in this step, this becomes 18 to the power 4, right? 18 to the power. Alright, on the other hand, if I were to expand this product, 6 times 3 to the power 4, it becomes 18 to the power 4, or which is stating that 18 multiplied by itself 4 times, right? And when you solve this product, it comes out to be 104976. So this result, what we obtained through expansion, is the same result what you obtain going directly through this formula. So basically the key point is, remember this simple rule that when you're multiplying two numbers that have different base but the same powers, then the result of the product will be the bases will get multiplied and then raise the power n, which is the same as the power of these numbers individually. Okay, now let us go take a look at the fifth law. Let us look at the fifth rule here, and the rule is about division of two numbers that have the different base. So if I have two numbers, p to the power n, and divided by a number which is q to the power n. So the powers is same, the bases are different, correct? So in this case, just like what we did in multiplication, we take the power out and the bases get divided and the power remains same. So this can be simply related to this example. Let's say my first number is 6 to the power 3, okay, and the second number is 2 to the power 3. The base is different. The first number has 6 base and the second has 2 base, but the powers are same, okay. So using this logic, we can quickly say that this result is equal to 6 divided by 2 to the power 3, or in other words, it is 3 to the power 3. Okay, now let's see how you solve it here. Okay, 6 to the power 3 is simply 6 times 6 times 6, right? And 2 to the power 3 is also 2 times 2 times 2. This is numerator, denominator, and we know that 2 cancels 6, it becomes 3, and likewise all other will be in the similar fashion, right? Or in other words, this is 3 times 3 times 3, which is equal to 3 to the power 3, because you are multiplying 3 times. This is the same result as what you would have obtained without going through this step of expansion, correct? So this is our fifth rule, simply stating that two numbers, same powers, different base, the bases get divided and the power comes to the power part as normal, okay? Alright, let us give a quick recap on all the 5 rules or 5 laws of exponent we have learned so far, alright? So the first one is when you're multiplying two numbers that have the same base but the different powers, their powers will get added and the base remains same. The second is when you're dividing two numbers that have the same base but the different powers, their powers will get subtracted, and that is for division. Okay. The third is when you have a number which is already in exponent form and there is a power to that exponent as well, then the powers will get multiplied respectively. And the fourth is when you're multiplying two numbers that have the same powers but different base, their bases will get multiplied and the powers remains the same as written right here. Okay. And finally, when you have two numbers, they have the same powers and different base, and when you're dividing them, the base will get divided respectively and then power will remain the same as it is on each individual number. Okay. In addition to these 5 rules, there are also few more things that you might want to remember all the time, and this will help you a lot in all the computation. Any number raised to the power 0 is 1 always, okay? And when you take 1 and you raise it to any power, let that power be n could be anywhere from 0 to 20 or million, it is always 1, okay? And we are talking about the positive number 1 here. Another quick trick you always might want to remember is when you take a negative number, negative 1, and you raise it to the power n, it can result in two outcomes. Outcome 1 will be if n is even, then this result will be always 1. If n is odd, then this will always result in a negative 1. Okay? If you take a number 0, raise it to any power, it will always remain 0. Okay? So this is all the rules or laws of exponents, and let us go practice on some quiz and exam topics to strengthen our understanding on the laws of exponents. Okay?